Well, hi there. Today we're continuing on with our plant startup. Last time we had purged the boiler and had igniters running. This step, we're going to start warming up the boiler. We will use coal to warm up the boiler. You could use igniters. In the past that's been done, but it creates a lot of soot and it can build up on the air preheater. Then you have soot fires in the air preheater. So right now we have a Pulverizer igniters on. We're going to start the lube oil pump for the gearbox. It's a small pump and recirculates oil to maintain lubrication of the gears. Okay, we have the secondary air fans are running. Now we have the induced draft fans are running. So we have pretty good draft in the furnace of -0.5. Drum levels -4.3. We want to just be right above the permissive level, as low as we can, because the drum's going to swell as it heats up, and we'll have to dump excess water. So now we're going to start the primary air fan. We create a trend of the motor current. These are pretty high-powered motors. This one's about 3,500 horsepower. It runs 7,200 volts. So there's a lot of heat produced during starting. These motors have limits on starting them. You can only start 3 starts per hour, and they got to run so long in between starts. So you just can't keep restarting these, you'll damage them. So we're going to get ready to start. We have an operator heading out there to verify that it's ready to start. It's always a really good idea to have somebody buy the equipment when you start it. Come in, Brian.
Go for Brian.
Yeah, you want to verify a alpha primary air fan is ready for a start. Also make sure there's nobody in the areas.
Out there and it looks good. We're ready to start.
Okay, we'll start a primary air fan. Now we announce it in the plant, just let everybody know. Attention all plant personnel, starting A alpha primary air fan, starting A alpha primary air fan. It's a good idea to let everybody know that you're starting large equipment. Okay, we'll start A. It's pulling 400 amps. You have about 24 seconds or so, and it should be back down by then. Okay, it started. Now the fan dampers will move. The fan dampers are closed to minimize the starting load on the motor. The outlet dampers will start opening here. These fans provide the motive force to move the pulverized coal out of the pulverizers. They provide air. Will be about 50 inches water column, 56 inches water column running. Okay, the outlet dampers have gone open. We can check the lube oil skid. These are the vibrations on the bearings, temperatures, key phaser. This looks at any couplings breaking. Here's your motor stator temperature. These are bearing temperatures. We have a lube oil pump running. It uses a circulating lube oil system to provide oil to the bearings, yet these bearings have slinger rings in them. So this mostly is for removing heat from the bearings. Okay, we have A running. Now we're going to make a quick trend of the B. Trends are really a good idea. You can always put more information on them to track stuff. Okay, we're going to get B started. It's pretty loud out in the fan room when you start these. Come in, Brian.
Go for Brian.
Yeah, ready for a start on B. Bravo, primary air fan.
Alpha startup looks good. We're ready to roll B.
Okay, starting B. Attention all plant personnel, starting B, Bravo, primary air fan. Starting B, Bravo, primary air fan. Please avoid the area. Okay, you're starting the primary air fan. There's a lot of heat in these motor windings when you start them. Once these are running and we have the pressure set, then we can go ahead and start the pulverizer. Quick check, motor temperatures are good, bearings. These are the air preheaters here, the two primary air preheaters. Part of the air goes through the air preheater and is heated, and part of it's bypassed, called the tempering air. This is mixed at the pulverizers to maintain about 144 degree outlet of the pulverizer. This hot air helps dry the coal so it grinds well. And it's also used to blow the pulverized coal out of the pulverizer. Okay, both dampers are open. Now we're going to start opening the inlet. You want to be kind of balanced on these two. Each one feeds 4 pulverizers on the opposite side of the boiler. There is a crossover between them. It's a plate with holes in it to kind of minimize the flow between the two. Once we get close to our set point, then we'll put it in automatic. Has some deviation alarms coming in. One thing, you don't ever want to have a bunch of unacknowledged alarms. Okay. Get a little closer to the set point, then we'll put it in auto. Okay, throw them in auto. The way these are set up, the B fan is biased off the A fan. So on the A fan you can set the set point for 56 inches water column. And in the B controller, you can bias off that. You can add more or take away from B to balance the flows or whatever you want to do. Usually run pretty good together at no bias. Okay, primary air fans are running. Now we'll go back and start the pulverizer on coal. We have the Aux boiler running right now. It's providing steam seals. Steam coming in the Aux Steam right now. It's about 160 psi, 29,000 pounds an hour. Gland steam. This is sealing the turbine so you can pull a vacuum on it. It's feeding steam to the low pressure side through the steam seals to keep the air out. Part of the steam goes in, then part of the steam comes out and is collected. It goes to this Gland steam condenser and an exhaust fan on it. It pulls a slight negative pressure. You got 17 inches water column right now, vacuum on it. So this prevents steam from filling up your turbine room. What doesn't go in is collected and removed. On the high pressure side, when it's running, there's excess steam leaking out past the turbine seals, and this is collected and used to seal the low pressure turbine, called a self-sealing turbine. So right now we're using Aux Steam through this valve to seal it. You'll go to main steam next once you get the boiler running, and cold reheat's usually the steam that is used. Once it's up and running, there'll be excess steam that goes over the spillover to the condenser, just to maintain about 4 psi. Okay, back to the pulverizer. We have an operator out looking at it right now, walking it down. There's a couple of screens you can use. You can start off this one, or you can use this startup screen. Right now we're set for 20,000 pounds an hour for startup. Usually it'll start 36,000 pounds an hour. So we'll have to inert the pulverizer first before we can start. We'll use the mill graphic, that way it's a little easier to follow. Got a 120-second timer for inerting. The purpose of this, it floods this with steam down here to put out any hot spots, or if you have any smoldering pockets of coal. That way you don't have a fire when you start it up. It's a permissive to start it. Here's some of the permissives that have to be met before this pulverizer will start. We have to have the permission to light the coal. Pulverizer not running. Pyrate's hopper outlet valve is open. This is for removing tramp iron, rock, and stuff out of the pulverizer. It's down the ground floor. It's cleaned out every couple hours. Use a water jet, pull any accumulated debris out. Feeder outlet not plugged. Master fuel trip reset. Cooling water, lube oil adequate for the pulverizer. Sleeve dampers in lighting position. We just got the temperature alarms for the inerting steam, which is we should have. All igniters are in service. Hot air damper closed, temporary air damper open. Big thing is the seal air path on these. That keeps the coal dust out of the bearings. Okay, we've almost hit our 120-second timer. Oh yeah. Check with the operator, make sure we're good for a start. Come in, Brian.
Go, Brian.
Yeah, is A Alpha Pulverizer ready for a start?
Yes, it all looks good. We're ready to start A Alpha Pulverizer.
Okay, ready to start A Alpha Pulverizer. Attention all personnel, starting A Alpha Pulverizer. Starting A Alpha Pulverizer. Please stay clear. Okay, we have a problem with the igniters. It's not showing it's made up. Try to restart it. Have to have the guy go look at it. Something didn't make up there. Come in, Brian.
Go for Brian.
Yeah, you want to look at a Pulverizer igniter number 2.
All right, checking out a Pulverizer igniter 2.
Shows it's extended and ignition, air, and oil is open.
All right.
Come in, Brian.
Go for Brian.
Yeah, E2 igniter just came in.
Okay, sounds good. I'll keep looking around here, see if anything else is bad.
Okay, I'll go ahead and start the Pulverizer. Igniters are always a problem. They have to go in and they have to light. Flame scanner has to see it. Okay, we'll go back to a Pulverizer. Check the start ready permissives. Okay, we lost the inert. They time out if you don't get the Pulverizer running a certain amount of time. So you have to go back and re-inert it. Safety precaution on them. Without having the inert done, you lose your permissives for opening up the air valves. On this other screen, we have our Precipitator running. We just have 2 rows, 3 and 4. The front rows have 2 TR sets, transformer rectifier sets, putting about 50,000 volts out to the plates to knock out any particulate. So most of your ash is dropped out in the first 2 rows. The back rows, they're more for just cleaning up anything that gets through the first rows. So we'll start up with row 3 and row 4 for startup. This one, the TR set powers. They run off a 480 volt, and it steps the voltage up to what is needed. So this one here is in 1,000 volts, so about 35,000 volts. Okay, we got a nerding alarm. Now we can go down and look at the wrappers. These are what knock the particulate off the plates. So these run on a program based on timers. There's no ash coming through right now, but this is required to be in service before we start up. The next thing we'll have to put on as soon as we get the Pulverizer running is what we call a DSI, dry sorbent injection. This removes sulfur out of the gas stream. So we're down to 0.3 ppm sulfur emission. That's the maximum. Usually we run way underneath that. While waiting for the Pulverizer's done inerting. We have our open ready for the seal air. The seal air provides clean air to the bearings down here to keep the coal dust in and also keep dust from coming out and getting into the bearing. The seal air is also provided to the rollers inside and the other parts here. Okay, this is the main air coming in. You have your hot air coming in from the primary air fan through the primary air heater. This is the tempering air, it's the cold air that's bypassed. Next thing, we'll bring the pressure up on the pulverizer. It has to be at 10% open to get a permissive for start. You can't go too fast on this or you'll reject the primary air fans. Okay, you'll have to get the sleeve dampers yet. Okay, we have all the permissives made up. Okay, now we're going to open the burner shutoff dampers. These are valves that shut off any cold airflow to the boiler. When the pulverized trips, also prevents backfeeding. I like the other screen for this, it's a little quicker. So at this point, this is called the pulverizer being aired up. BSOs sit right on top of the boiler. Physically, they sit right up in here, right on top. Everything has limit switches and has to be made up before you can go the next step for safety. Okay, we have our start ready. We're going to watch the amps on this. These are about 800 horsepower motor. They run 7,200 volts also. We have our roller seal air DP of 30 inches water column. This ensures that we have adequate pressure to keep all the bearings and bushings free of coal dust. Okay, now we have to go up to 29% to get permissive to start the coal feeder. And these pulverizers usually will leave the classifiers alone on top. They kind of help with the coal fineness. We have two older style pulverizers. You have to adjust the classifiers from startup to running. But this newer style, they seem to do a pretty good job. You don't want big pieces of coal blowing in. Yeah, it cuts down the efficiency. These also have permissives. We're ready to start feeding. First you have to open up the outlet on the coal feeder. We usually open this one first, just in case it doesn't open. You don't dump a bunch of coal in the feeder you got to deal with. There's air pressure in the pulverizer that's feeding up, pressurizing this right now. Okay, this is the silo outlet. These have a habit of plugging up. They have coal build up. They're a sliding gate type valve. So you can use water and wash them out. Get the coal out of the way, then they'll open. Okay, we got to start ready. These are gravimetric feeders. They maintain a certain amount of coal weight on the belt, and then you adjust the belt speed to control the feed rates. Okay, we're feeding 20,000 pounds an hour. At this point, we have to start the DSI, dry sorbent injection system. Over here, this uses air compressors. These provide the control air and also air for purging out the lines. So we have the instrument airs running. We'll start with mill 1. I think we'll use 1A. This here has called the Viper mill. The product goes through here and it's spinning bars that crush it very fine. So it increases the more surface area and increases the efficiency of the DSI. Oil pumps tripped to reset and start on auto. Okay, started, put it in auto. This system's pretty automated. We're going to change the mill mode to process. These are the injection blowers. I have a dehumidifier. Any moisture makes this product cake up or produce like a rock. Pretty hard material, plugs up lines. So dehumidifier goes through a blower. Heat exchanger. This cools the air out of the blower. And then our valves. We got about 4.6 psi. Okay, we got the blower running. 4.45 psig coming down here. It's going through the Viper mill. This bypass valves are for when you water wash the Viper mill, the product will build up on it. So use water to wash it. Speed slows down, water blows on it, cleans up any buildup, and then it goes down to the sump. Right now it's changing to process mode. You can run without the Viper mill, it just bypasses it here. Right now it's timing down on the counter. On these you can set the emissions. It's 0.3 ppm. That's kind of the high point. Usually it runs a little bit less, or we'll bring it down a little bit if we can't reach it. This is all the setup for the DSI. Okay. So this stuff here is called Trona. It's what they make baking soda and soda ash out of. It's mined down in Wyoming. Now we've tried baking soda also, but Trona seems to work quite well for knocking the sulfur out. You can use wet scrubbers also, but this product worked really well in the plant. It was injected right above the air preheater, and by the time it got out to the precip, it knocked out any particulate there, and it removed the sulfur pretty good. Also inject activated carbon, uranium, mercury. Okay, we've timer in sequence 8 now. Viper mill's coming up to full speed. It's a variable frequency drive motor. Once we get up to speed, it should swap over. These silos hold about 4 rail cars worth of product. Any moisture in them, it rocks up, so there is a fan running on top. We try and run dehumidified air through here, just to keep any air out. Okay, it's in process mode. From here, it goes out the injection lines. This is the north primary air heater, north secondary air heater inlet, south secondary primary. So this is where we're injecting the trona. This is the flue gas right before it goes through the air preheater. It detects blockages by looking at the temperature difference. Okay, now what we got to do, we're starting to warm up the boiler. We need to make a graph so we can track it. We need to be at 600 psi and 600 degrees, about the same time. Create a mini trend. You can modify it. Adding points is really quite easy with this. You just go click on what you want, drag it over, drop it in the square, and you have it. Now we're going to modify them. Right now it's up to, like, the throttle pressure is 0 to 3,000. So we're going to change the scale limits. This is user entered. It's really a pretty good program. I'm going to go 700 and the low of 0. Okay, this is the superheater. Same thing. We want them both to be the same scale range, that way we can watch them, make sure they come up together. Okay, there are two superheat and throttle pressure. One thing you can also do on this is put on a grid if you wanted to. It sometimes can be a little bit more confusing, but it does show how much stuff's changing. We have our drains on the steam turbine full open. We're going to pinch these back a little bit. These are limit torque valves. They don't stop right when you want them to. You got to stop a little bit early. So you can use these to regulate the pressure you're dumping the steam to the surface condenser. This also warms up the main steam line. These are right by the throttle valves for the high pressure turbine. So you don't want any moisture going to the turbine. Everything has to be warm. They want at least 50 degrees superheat before you roll it. We can leave them open a little bit more just to try and warm up things. But you can change the boiler temperature by how hard you fire, and you can open up the drains to control the pressure. These are the rest of the turbine drains are all open, and this plant red means open, green is closed. You have your throttle Your governor valves for high pressure steam. So these drains sit right in front of it. One thing we need to do is close the dampers on the reheater, which they are closed. You don't want steam going in, don't want flue gases going through the reheater because there's no steam in there. Another thing we can do is check the temperatures. It's kind of nice on this. This is the finishing superheater tube temperatures. They're all quite low because we just started firing them. These are 2 1/4 chrome steel tubes. These are the division walls. These expose more to the firing. You need good steam flow through these to prevent damage to them. And then we have the reheater tube temps. Need all the sections and certain tubes picked. We don't want to exceed 1,000 degrees on the furnace outlet. And on the steam drum, you don't want more than 215 degree difference on the drum. That could cause the high thermal stress. You want these temperatures, the bottom and the top temperature of your steam drum to be fairly as close as they can, because you got water in the bottom and some steam in the top. Because right now it's just circulating. The economizer recircs, they bring water from the economizer up to the steam drum, so you get kind of a natural circulation through the economizers, because we're not putting any water in right now. These are the division wall drains. We'll leave these open for a while. These are the startup vents on the drum. We'll close these about 25 psi. These are electromatic relief valves. You can manually open these if you have high pressure. They're set to open before the other safeties because they sit on the boiler outlet. That way you maintain steam flow. Here's the drum level transmitters. You got your pressure transmitters. 3 transmitters on A2. This here will take an average of them. And you can also take them out of service if you need to work on one or calibrate it. Now we wait. Try and bring this up. At 25 psi we will close some vents and stuff, and at 300 we'll go ahead and swap over from the aux boiler to main steam. We're going to start recording again. It's kind of a long wait from 0 to 25. It takes a while to heat all that water up and get it boiling. We're at 25 psi. We have a bunch of valves we got to change. Come in, Brian.
Go for Brian.
Yeah, we're at 25 psi. You want to go ahead and do section 3.8 of the procedure. He's going to close a bunch of drains and vents on superheat. Now we're going to close the boiler drum vents. These just let off any non-condensables and air out of the drum when you start up. It's a pretty normal procedure. Close them about 25. These are division wall drains. I'm going to go ahead and close them. In the past, they've been throttled down and then closed at higher levels. Big thing is get any moisture out of the steam lines. It seems kind of weird having moisture in steam, but any water droplets or any water can cause water hammering and damage. Okay, another thing we'll have to do is flush all the drain valves that we open. We drain the boiler. We'll have to open them up a little bit. flush them and then retighten them. We'll do this at 25 psi and 200 psi. Any leaking water through these valves will destroy them fairly quickly. Plus you lose plant efficiency. There's a lot of drain valves, so it's critical to make sure that they're all seated correctly. If somebody doesn't shut a valve right, it will damage the seat in time. So far we've heated up. We've brought the pulverizer up just a little bit. Right now we're feeding 24,000. This is the graphic for the flames. A pulverizer and E are the very low ones. We'll usually start with the low pulverizers. Provides more heat for the water walls coming up. When the plant's running, usually your lower ones will give you more pressure than your upper pulverizers, kind of give you more superheat. You're firing up a little bit higher up in the boiler. At this point, right now our throttle pressure is 28, 29, and superheat's 194. So we'll wait until our next step will be about 300 when we start swapping over the pressures. So we'll stop the video here so we don't bore everybody any more than we have to. So next time we start will be about 300 psi. Okay, we've been at this about 4 hours now from when we first lit the coal fires. Our throttle pressure is 308. Average superheat temperature is 434. They're starting to come together. So we want to hit about 6 and 6 before we roll the main turbine generator. About 500 psi will start up a steam-driven feed pump. Our temperature is still a little cool on the pulverizer. So we'll go to the prime ID fan control. Okay, we're changing the dampers to the air preheaters, trying to force more flue gas and more heat through the A air preheater. This should give us more heat for the pulverizer. That's a problem starting up. You don't have enough heat on these to work well for the cool. These dampers get adjusted quite a bit trying to maintain air heater temperatures, and also keeping the air preheater from getting too hot. Your temperature limit's about 400 degrees on the ducting going out, so a lot of that heat can be reclaimed with the air preheaters. These controllers always have to be highlighted before you click on them. It's a safety issue. That we just can't change controller without selecting the right controller. Okay, we're going to start swapping the Aux Steam over. We got 318 psi on the main steam header. First, we're going to open up the block valve and just let the line start warming up. Right now we're burning diesel in the aux boiler for startup. So this will provide steam to the steam seals. We can put on the fan room air heating and any plant heating if it's needed. Big thing, you always want to keep steam on a turbine if the steam seals are on. If you lose your sealing steam, you need to kill the vacuum on it. You don't want to pull out cold air across the shaft. It can cause problems cracking and rubbing on the seals. We're going to open this up just a little bit to start warming up. You'll have to call the guy to run the aux boiler just to let him know, because he's going to start dropping flow on it. A lot of these valves have to move quite a bit before they open. They're driven close. Okay, we're gonna Pulverizer's been doing pretty good. Only have 4 inches DP. This is measuring the differential pressure across the pulverizer. So if it starts building a lot of coal up or plugging up, this number will start climbing. If it gets up above 28 or so, you'll have to start cutting fuel. Put more air through, try and get the coal out of it if you can't get it. If it plugs up, then you have to take it offline. Then you have to grind it out, kind of dump all the coal down to the pyrite hopper. Okay. We're going to start swapping over from Aux Steam. I call the operator. Come in, Brian.
Go for Brian.
Yeah, we're going to start taking the aux boiler offline. We got 325 on throttle pressure, so I'm going to start pushing you off.
All right, sounds good.
It has to be kind of a coordinated effort because he's going to have to cut fuel down there. This controller is set for 184 psi. Right now we're coming off the main steam header. When the plant's running, this would be 2400 psi. Right now it's about 327. Usually it runs on the cold reheat. So the steam's already gone through the turbine and it's being reused. See our aux boiler flow is starting to drop. We're down to 20. We'll have to put a little more firing on the pulverizer here because we're using a little bit more steam. Lines come up to 158. These two pressure transmitters. We're going to go back to a pulverizer. Let this sit for a minute on the steam. Click on the flow and it'll bring up your feeder, or you can also get this from the Pulverizer control graphic. Once again, you got to highlight it. We need to bring it up to about 30 on the firing rate. We'll be looking at this number here, and also on the flame graphic it shows the same number. So 32,000 pounds of coal an hour is going in. Aux boiler's down to 15. Okay, at this point I'm going to call the Operator on the Gatronics is to stay off the radio. Brian, line 2. Brian, line 2. Yeah, Brian, how's it going?
Brian on line 2 here.
You're down to about 13k pph. How's your boiler doing?
It's going pretty good, I think. We're on schedule.
Okay, as soon as you come offline and take over, you'll need to do the low water level test on it and then add the chemicals for shutdown.
Alright, sounds good.
Sometimes it's best to stay off the radio. Nothing worse than trying to get a hold of somebody in an emergency and everybody's talking. At least our chart's moving up again. The pressure's starting to gain. Big thing with steam lines, you need to let them warm up slowly. You need to have all the water out of them. Been a lot of catastrophes from water hammer. It's incredible the amount of power a water hammer can have. We also have an alarm in, had the A coal silos left in 50 tons. So we'll start up the coal feed. At least we're to 160. As soon as we get close to 180, we'll put it in auto. It's probably going to be almost all the way open. He's down to 7,000 pounds steam flow. We're also taking quite a bit of steam through the aerator for pegging. We got the drain open on it, just trying to clean up the feed water. Drum levels come up a little bit. We haven't had to open up the drains to lower the drum level yet. Okay, we're full open. I'm going to put in auto as this pressure comes up. This valve will start closing down. Box boiler slowly coming off. Okay, A silo is under 50 on 46. You don't want to dump a whole lot of coal in these before you start up, just in case it doesn't start. Also, the coal will pack in the outlet here and plug them up. We have 86 tons in distribution bin. Belts are starting up. This here's the feeder belt, controls how fast. Sometimes we'll slow this down. You first put coal in the silo just so you don't pack the coal in tight in the bottom. This will fill automatically. This is the control silo. Fills to about 400 tons. These alarms up here are for if you have somebody pulls the emergency cord, belt misalignment, discharge chute plugged, failed to start. They use nuclear detectors for detecting pluckage on the chutes. Here's the boiler water. Temperature spreads pretty good on it. This unit has two economizers. You have a lower economizer that sits down lower in the flue gas stream. Then you have the upper economizers actually in the boiler back pass section. Okay, we're going to put the damper in automatic. Set point's 150, that's a little warm. These are pretty sensitive to temperature. Sometimes they make a lot of noise, you cool them down a little bit and then they quiet down. So we're shooting for 143 degree outlet temperature. This will be the coal air mix coming out of the pulverizer. This is maintained by your hot air damper and your tempering air damper. This bypasses the air preheater. This is coming through the air preheater. It shows about 190 coming in right now and 133 going out. There's an air-fuel ratio you have to maintain. On pulverizers, we're pretty high. As this temperature heats up, this is going to drop off. So usually you want like 180,000 pounds of air per hour per about 80,000 pounds of coal. Okay, we're sitting at 331. The next thing we're going to do at 500 psi throttle pressure, start a feed pump. Right now we have the electric feed pump running over here, and we're just going through a flow control valve. It's like a 1,000 horsepower motor. This is used for filling the boiler with and for startup. It doesn't, above 1,000 psi, this pump really doesn't do much. So it's mostly just a startup pump. And you have a level control valve. Once we're up and running with the main steam turbines, this will be full open and just control your level off the turbine speed. This goes to 3-level element control, about 1,400 psi. Right now it's single element. So it's a little bit erratic running, but our drum level hasn't come up too much yet, so I have control of that. Furnace pressure is holding good. Here's your throttle pressure and superheat temp. One thing we could check is the temperatures on the back pass. Reheater 495, 480. That's okay. There's no steam flow right now on that section. That's why you kind of have to be careful with it. Finishing superheat, looks like it's right around 500. Division walls, about the same. This here's your boiler temperatures using infrared probes. So right around 500 degrees on the boiler. That's fine. Okay, the next thing will be 500 psi, starting a feed pump. Okay, we're now at 7.5 hours on the startup. We've edited a lot of it. Usually you'll get a startup time. They'll want you online at a certain time, so all this stuff has to be worked backwards to figure out when you need to start the pulverizers. It usually take about 48 hours from cold start to getting the plant up and running with all the steps. So we're 500 psi. At this point, when you put the electromagnetic relief valves into auto, like I say, these are the first relief valves to open. They're right on the outlet of the boiler, so it maintains steam flow through all the superheat tubes. And they can also be opened in an emergency from the control room. Okay, auto. Our next step is going to be to start a boiler feed pump. As you can see, we have the startup pump still running. We're feeding a little bit of water in with LV7 to maintain drum level. This pump has an automatic recirc valve on it. You can start and stop them if you need it, or leave it run. It's probably better to leave it run. You don't have the start stop currents on it. The auto recirc works pretty good. These are the feed pump turbines. Have A on the bottom, 2 pumps on 1 steam turbine. Here's your seal feed water. This is to seal the main feed pump. You got your heaters in between. The aerator temperature is good aerator level. Here's the lube oil screen. It's on turning gear, 15 RPM. You've got your main lube oil pump. And this pump here should be an auto for backup. And then you have a DC driven pump. Both feed pumps and the main turbine has a DC pump in case the plant goes black, you lose power. Its purpose is to get the machinery down without doing damage to the bearings. This starts about 10 psi and maintains lube oil pressure. Lube oil is about 70 degrees. That's about as low as you want it. Cold oils can be worse than hot oil. It can create vibrations in the bearings. Your pumps, you don't want to start them if oil is below 50 degrees. Different turbines have different requirements of oil temperature. Ideally, you want about 110, 115 going to the bearings. When we start up, we'll watch the eccentricity on the vibration panel. These turbines will measure eccentricity up to 600 RPM, looking for any rotor, bow, any distortions that's caused from being in hot temperature on top, cold on the bottom, or sitting without being on turning gear. The weight of these will cause them to sag a little bit over time. Okay, here's the turbine start screen. We'll need to call the outside operator, make sure he's walked this down and has the warm-ups closed. Come in, Brian.
Go for Brian.
Yeah, we're ready to start A alpha boiler feed pump. You have the warm-ups closed, and is it ready to start?
Yes, I just got the warm-ups closed on alpha feed pump. You should be ready to start it.
Okay, ready to start alpha feed pump. Once again, we'll call it out. Attention all plant personnel, starting A alpha boiler feed pump, starting A alpha boiler feed pump. Please stay out of the area. Okay, it's on turning gear. Have to open the stop valves. Oh, we'll latch it first. To latch it. Let's just reset the trip logic. These are both the stop valves. This pump has 2 separate steam supplies. A high pressure line, which comes off the main steam, and then the low pressure comes off the IP turbine exhaust. So we're going to be using the main steam to run this. Turning gears tripped. Control mode. Speed setter. This just runs it manually. I'm going to type in 2900. 800 RPM a minute. Here we go, 2900 RPM is our target at 800 a minute. Hit go, we're watching the eccentricity on it. We're going to have to hold because the set point's running up and your low pressure valve has to come full open first before it'll allow the high pressure valve. So there's no steam on this side, the low pressure. So we're going to rely on the high pressure steam. Otherwise this thing will wind up too high and then the valve flies open on you. It's usually a good idea to have somebody just monitor it for any weird noises when you start up. Usually we'll run on the low pressure valve. So if we would not have held this and just let it go, this would have been up to a fairly high number, and then all of a sudden that valve would fly open and try to catch it. We won't do a trip test on this pump, but every 2 weeks you should test your lube oil pumps, make sure they auto start. Do valve tests, make sure the valves haven't stuck. These pumps come on and off so much that every day they're being cycled. Okay, it's still going open. Valve position. And once it starts moving on the HP stop, then we'll go ahead and let the speed setter control the speed on it. Meanwhile, we got throttle pressure's 516, super speed's 577, so we're catching that pretty good. Okay, we started to move. That's under H high pressure valve control. Now we'll go to our lube oil screen, let's check vibrations. Our eccentricity on the vibration monitor panel behind us looks good. Here's your main feed pump. Here's your turning gear. Steam turbines, about 13,000 horsepower. Then there's a gear reducer, then it runs the booster pump. Should see the oil starting to warm up here as it goes. Main purpose of this lube oil system is to remove heat from the bearings in the machine. As a vapor extractor, keep many oil vapors and explosive gases out of the reservoir. See, the vibrations look pretty good. Here's your thrust bearing. Now you got normal and reversed. About 18,007" will trip the turbine if you start losing your thrust bearings. The clearances are so tight in these. If this thing was to trip offline, you lose electricity, you'd have to turn these by hand. Use a wrench and turn it a quarter turn every 15 minutes just to keep the shaft from bowing. It's up to 1600 RPM. Once we're at 2900, then we can take auto control. You'll be used to run the drum. This up here is the rotor position. It's just showing how the turbine centered in the machine. If you warm up a turbine too quick, the small ones aren't too critical, the big ones are, your rotor will grow faster than the casing and cause problems. Or if you cool them too quick, the rotor will shrink quicker than the casing. Okay, we're up to speed. It should grab it here. Okay. Looks like it's finally caught it. We're going to go to the remote. The speed setter is just an automatic control to get it up and running. Now we can actually use the actual control panel. These just click on the feed pump, brings up the control panel. We're going to shut off the startup feed pump. We're using more steam now, so we'll have to put a little more fuel on the pulverizer. The level control valve, we'll throw it in auto. Okay, we got a manual reject alarm in. Because you can only have LV7 can be in auto or the feed pump auto. We can't have them both in auto. So it's in manual. We just have to maintain a differential pressure across this valve. So we'll play with the turbine speed occasionally. It's just running in manual. Okay, we'll go back to the pulverizer. Temperature's doing pretty good. DP's not bad. Put on a little bit more fuel because we're using a little bit of steam to run the feed pump. Probably up about 38. Try and maintain our trend. Check the ID temperatures. Looks like it's doing pretty good there. Our next step will be rolling the main turbine. We cut the drain valves back a little bit to about 26. This is maintain steam flow from the boiler down to the turbine. It's kind of a longer pipe we're in, and it's a pretty thick pipe, so it takes a little bit to heat it up. Condensate. We're using steam, Aux Steam, to heat the deaerator with right now. We've been doing that all along. The drain's open a little bit just to maintain flow. Our low pressure feed water heaters are bypassed right now. These won't come in play until we have about 180 megawatts on the plant. These are later stages than the LP turbine, so there's not a lot of steam pressure. Right now they're not doing anything. Feed water heater 3 is bypassed also. That's done locally. We just got one polisher in service, one condensate pump. And our next, here's our plant chemistry. pH is good, cat conductivity's good. O2 is a little high, but that's okay for startup. We're not adding any amine yet, which is ammonium hydroxide. DA has 16 coming in, O2, 4 coming out, so it's working. Boiler chemistry will be pretty screwed up for about a day or two till we get things up and running. But all the chemistry looks pretty good. Big thing, your sample has to be 25 degrees Celsius to get consistent results. I guess we'll check the feed pump again real quick. Vibrations look good, temperatures are coming up, oil's warming up. So that feed pump looks pretty good. Like I say, they'll give you a start time. They want you on hour ending, whatever it is. So you have to kind of figure out when you need to start various sequences to have the breaker closed at the allotted time. Okay, we're 8 hours and 15 minutes into startup since we lit the fire in the pulverizer. We have 605 on throttle pressure, 608 superheat temperature. They came in pretty good. Graph. Now we're going to start the main turbine generator. Get a hold of the operator, walk it down, just make sure everything looks good. All the wires and everything's hooked up to it. Come in, Brian.
Go for Brian.
Yeah, ready to start the turbine generator.
Okay, we're already out here. Start it whenever you want.
Okay, we're going to roll it, then trip it.
Sounds good.
Have to latch it. Okay, valves are closed. Operator auto. We're just going to roll it to 600 RPM to do rub checks. We'll go about 100 RPM a minute, kind of slow, just to make sure that it's not going wrong. We have eccentricity on it. There's a lube oil screen. We have our lift pumps. Oil pump speed. Okay, turning gear just kicked out. 20 RPM. Eccentricity looks good. Have 3 mils eccentricity. This thing's like 120, 130 feet long. So you have a chance of getting rotor bowing. Okay, it's rolled up. Oil's a little cool, but it's okay, screen showing basically the valves of the turbine. Okay, it tripped, everything went closed. These are the stop trip valves, these are the governor valves. These are intercept valves for the IP and the intercept stop valves. Come in, Brian.
Go for Brian.
Gonna latch and roll again.
Okay, looked like a good test.
Okay. Put autos in. Okay, latched. Basically, intercepts have come open. Reheat stops open. Governor valves are open. One thing you have to do is reset the 86 lockouts, electrical lockouts for the breaker. They trip when you trip the turbine. Attention all plant personnel, rolling the turbine generator to 600 for rub check. Rolling turbine generator to 600 for rub check. About every 2 weeks, do a valve test just to make sure the valves are free to move. The speed's being controlled by the trip and throttle, or your main stop valve. It has a pilot valve inside that lets a small amount of steam through. The governor valves are full open right now, so your turbine speed is being controlled here. All the intercepts are open, and the reheat stop valves. We have the lift pumps. These pumps provide high pressure oil to float the shaft off the bearings at slow speeds. We're running on our AC bearing oil pump, and this is the AC seal oil pump. This is the DC pump, provides oil in emergency use. It's in auto. Turning gear, we're back to auto. At 600 RPM, we'll go out and make sure we have good flow of oil through the bearings. That's for unusual noises. Here's the seal oil system. The vapor extractor is running. DC oil pump is running for hydrogen gas drawing. We get good hydrogen pressure, 100% purity. This unit runs about 60 psi. Usually we start a little bit lower than this because it's going to warm up and expand. It has a hydrogen gas dryer on it, purity analyzer, hydrogen supply, and you have CO you use for inerting it. When you shut down, you use CO2 to force the hydrogen out, and then you use dry air to get rid of the CO2. When you put it back on hydrogen, you have to do the same thing. You have to purge with CO2, then go to the hydrogen. Okay, it's rolling up. One thing I didn't mention on the feed pump, we're looking at another screen. We have other screens up that have graphs on it to watch flows and various aspects of it. This is your turbine screen. Here's your rotor position and mills. Differential expansion. This is kind of the expansion of the rotor, between the rotor and the casing. You have your bearing over here. These are relative vibrations, which are the vibrations between the shaft and the bearing. Thrust bearing temperatures, bearing metal temperature limits, vibrations, eccentricity. It's down to 0.6. At 600 RPM, this is no longer being used. This screen will make sure the exhaust hood sprays are in auto. These provide cooling water for a low pressure turbine and low flows. There's not enough steam flow going through the turbine. The backstage blades can become fairly warm. We're tracking the temperature down here on it. First stage steam temperature, first stage metal. Quite a mismatch there. You have your high pressure gland steam. This is steam coming off the high pressure side. IP exhaust, it's leakage. Gland steam is about 340. We control the temperature on that based on the rotor temperature. The screen here shows the blade resonance range. These are harmonics. You don't want to stay here very long. So if you have to stop the run up on the machine, you try and go in between one of the resonant ranges. You have exciter critical speed here. These are absolute vibrations. This is the actual bearing housing vibration. So it's a little different reading than the other one. But if you have a problem, they're both going to come up. Casing expansion. It's grown a ½ an inch so far. Rotor position in mils. This is probably the big one. You're starting up to make sure that the turbine isn't growing faster than the casing, so you have a contact. Okay, at 600, we're going to send an operator out to check the machine over. Yeah, go back to him. Temperatures are warming up. Vibrations are good. I got your rotor short alarm, rotor long alarm. Limits, everything looks like it's where it should be. Make sure these are auto. Okay, I'm in auto mode. Okay, we check the operator, see what he's found out there. Come in, Brian.
Go for Brian.
Yeah, it's a turbine ready to accelerate to valve transfer speed.
Yes, everything looks normal out here.
Okay. Okay, we're going to accelerate up to valve transfer 3450. The speed you go at depends on the condition. If the turbine was considered hot, you'd want to go fairly quick so you didn't cool it off. But we're at a cold startup, so we'll go a little slower on it. Sometimes you have to go really quick if you're come offline, try to go back on quick and your turbine casing's really hot. Steam goes through the control valves, it drops the pressure and it does cool it a little bit. We have quite a few different charts and graphs for determining how quick you can start up. This screen here is pretty important. We have this up on the other board. This is monitored all the time. You have relative X vibration and relative Y vibration of the shaft. Big thing is want to make sure the 86 relay is reset or you won't get very far with this. There's one item that gets forgotten. Okay. Now at this stage we're going to check few items right there. Make sure the Gland steam is doing well. We have our pre-start checklist. So I'll have to sit at valve transfer for a while until these temperatures equal. The important thing is to try to hold the plant pressure and temperature uniform, otherwise it extends the hold times. Both throttle and steam are pretty good at 640 each one. Here's the feed pump. Lube oil. Showing about 109 coming out of the coolers. Make sure the turning gear's in auto. Good idea to go through the screens and make sure everything's in auto. At least to start a shift or after you change a piece of equipment. Okay, at this point, it's electrohydraulic. This is high pressure oil used to operate the valves. So these valves are hydraulically operated. These are the ventilator valves. They get rid of any excess steam when the turbine trips, so you don't have a lot of steam in the high pressure end that's trying to be compressed, or creates a lot of friction on the blades and a lot of heat. Condenser vacuum, still running 2 vacuum pumps. Trying to maintain. Got 3.2 inches mercury, absolute. Different places will have different units they're using for the vacuum. Seal oil's important. This is what's keeping the hydrogen inside the generator. Try to maintain 10.5 inches, 10.5 psi seal oil pressure above the hydrogen pressure. So if we're at 60, this would be like 70.5 psi. Basically, the oil goes into the seal. Part of it goes in, and the other part comes out towards the bearing, which mixes with the bearing oil. Then that oil has an enlargement and a drain, which any entrained hydrogen is released and vented off. The other part of the oil comes down here to the hydrogen side receiver tank, and the hydrogen from here vents off, goes back to the machine. Hydrogen is really good for cooling, and it also has low windage losses. Okay, our lift pumps have shut off. Oil temperature is about 111, 14 psi. These pumps here will be swapped over at 3600. There is a pump on the end of the turbine shaft and produces high pressure oil, about 350 psi. That oil comes down to an ejector. The high pressure oil is used to move a large volume of low pressure oil, which feeds the bearings. And some of the high pressure oil goes for feeding the hydrogen seal. There's also an overspeed setup. Have a mist eliminator running. You get flammable vapors off the oil, and any hydrogen that comes back, you get mist and vapor off the oil you want to get rid of. Plus, it helps pull a slight negative on the tank, and it'll keep oil from coming out of the bearings, or vapor. It tries to pull a slight amount of air into the bearings to remove any oil vapor and mist in the room. So we're 2076. It's been, what, about 9 hours since we...
8.5.
8.5 hours since we lit the fire in the pulverizer. So go up to 3450 and that'll be valve transfer. A lot of these sections we've done other videos on a little more in depth. We just kind of showed how the whole thing fits together this time. There's a lot more stuff in the background that isn't being shown on this video we're looking at. But this is kind of the basic part of running the plant. You can see our pressure's diving off a little bit. Throw a little more fuel on it. The key is to hold the pressure even. Otherwise, your heat soak for valve transfer will take a lot longer. That's quite a little too much. Probably want this closer to 42 to 44, something around there. Pulverizer temperatures come up, about 143. Cold air mix coming out. DP's only 7. You want to watch your motor amps. They should vary a little bit. If they stay real steady, that's because you're skidding, and that means the rollers aren't moving. Something's jammed it up. The older style pulverizer, they had a ring pushing weight down on the wheels, and the wheels were like a planetary 3 tied together, and they rolled in here independently, and they were prone to skidding. This one, the rollers are stationary and the table turns, so it doesn't skid quite as much. They will plug up, and there's some other issues they'll have. Flame page, 44,000. Have to leave igniters on until you get a cold boiler. You probably want to go to 80. If it's warmer, you can cut them off a little bit earlier, sooner. Depends on the price of diesel. If diesel's expensive, you want to get them off quick. If you lose, you can lose all these. As long as you have one igniter in, you won't trip the boiler. So if you're having problems with a pulverizer, you can start a igniter on E real quick, and that would keep it from tripping. Drum level's doing good. LV7's controlling. The bearings and stuff look good, so this is the valve transfer screen. This is what these two numbers here will have to equal before we can transfer the valves. What that entails, you're putting the machine on the actual governor valves. The throttle valves go full open and the governor valves will be controlling. You have your chart here, which hasn't started putting data in yet. But okay, that is the startup from boiler purge complete until the turbine generator valve transfer.